This is Mr. Craig, and I'm going to talk in this video about if you're presented with a salt and it's placed in pure water, if it will cause the solution to become acidic, basic, or remain neutral. This is one of the concepts that's asked on the AP exam, and you should be familiar with the salts and what they do. Now, before we begin, one should know the 6 strong acids and one should know the strong bases. The strong bases are probably a little easier to memorize since you just go to a periodic table and you say, okay, everything in group 1A and then in group 2A, calcium on down, when it's with hydroxide, is considered to be a strong base. When looking at weak bases, they're not so easy to determine, but if you look at a formula and it has hydrogen at the end of the formula, typically that behaves as a base. The 6 strong acids you should know are hydrochloric, hydrobromic, hydroiodic, nitric acid, sulfuric acid, and perchloric acid. Those are the 6 strong acids. If you're not familiar with those formulas, I highly recommend that you actually take a look at those. Alright, these 7 questions here are 7 salts. I'll be asking you to determine if they'll cause the solution to become acidic, basic, or remain neutral when placed in pure water. Alright, let's look at number 1 here. Potassium hydroxide, when it's actually placed in pure water, the question here is, what will it do to the solution? Will it make it more acidic, more basic, or will it remain neutral? Hopefully you recognize that potassium hydroxide is a strong base. The potassium, which is in group 1A, will dissociate 100%, and when it's with hydroxide, it will dissociate 100%. So this will cause the solution to become more basic. That was an easy one. That was a good one to start off with. Looking at number 2, we have sodium acetate, and sodium acetate will dissociate into sodium ions and acetate ions. Now the question you need to ask yourself is, when you're looking at a salt, you need to split the salt in half. In other words, if I look at the back half of a salt, okay, in other words, if I take this and just analyze the C2H3O2, the back half of the salt will always be a conjugate of an acid. I didn't say if it was a conjugate of a strong acid or a weak acid. I just said of an acid. And then the front part of the salt will always be a conjugate of a base, whether it's a strong base or a weak base. That's up to you to determine. So when we look at a salt, you need to first identify what the metal is, and that'll be the conjugate of the base. And then the anion, or the nonmetal, will always be the conjugate of an acid. And then you need to ask yourself, what will these conjugates do? If I have a conjugate of a strong acid or base, that thing will do nothing. If I have a conjugate of a weak acid or a conjugate of a weak base, then it will behave as the opposite. So if I have a conjugate of, as I do in this case here, where I have a conjugate of a weak acid, then it will cause the solution to become basic. As we can see in the balanced equation here, where I take the acetate ion and place it in the water, what it's going to do is rip a hydrogen off of the water and attach it to the molecule itself, which will have on the product side here our acetic acid or a weak acid and the formation of hydroxide. So when looking at this, make sure that you're asking yourself this question: am I looking at an acid or am I looking at a base, the conjugate of that? And that should help you out in determining whether the solution will become acidic or basic. Looking at number 3, here we have ammonium bromide. If I take these 2 pieces apart, if I look at ammonium, I have a conjugate of some kind of base, and the bromine, I have a conjugate of some kind of acid. Let's start off with the bromine. What will the bromine do when it dissociates? Will it cause the solution to become more acidic or more basic or remain neutral? Hopefully you said that the bromine will cause the solution to remain neutral, because it's a conjugate of a strong acid, and conjugates of strong do nothing. In other words, if it's a strong acid or a strong base, it wants to dissociate 100%. So there's nothing that's going to reattach itself to that strong. However, if it's a conjugate of a weak, then it wants to either give away a hydrogen or take on a hydrogen, depending on if it's an acid or a base. Well, in this case here, the ammonium is a conjugate of a weak base, which you should know as ammonia, NH3. So when we look at the ammonia, or I'm sorry, the ammonium, the NH4 with the +1 charge, what it will do is drop a hydrogen on the water and make hydronium here, which behaves as an acid. And we're left with our conjugate base here, ammonia. So in this case here, it causes a solution to become more acidic. In example number 4, we have lithium chloride. Lithium is a conjugate of a strong base. Chlorine is a conjugate of a strong acid. So this solution will dissociate 100%, but neither of these ions will do anything to water. Therefore, in this example, this salt will cause the water solution to remain neutral. Nothing will happen. Number 5. We have an interesting salt here. And this is one that I would expect to see on the AP exam. And you might look at this and just go nuts thinking, what in the world's given here? You got to remember, you're never going to see a weak acid, a conjugate of a weak acid with a conjugate of a weak base. That will never ever happen. You may have a conjugate of a strong acid with a conjugate of a strong base, or you may have a conjugate of a weak acid with a strong base, or you may have a conjugate of a strong base with a weak acid. But you'll never ever have a conjugate of a weak with a weak. So when you see something that looks like this, you have to ask yourself, who is the strong? Or where is the strong? There will always be at least one strong acid or base in every salt that we're going to be dealing with. So when we look at this problem, if we separate the metal from the non-metal here, as I have in the balanced equation here, you'll notice that at the end of this, we have a conjugate of a strong acid, nitric acid. And what do conjugates of strong acids do? Nothing. So we need to focus our energy on this C5H5NH. Don't worry about what the name of that thing is, but do worry about what it will do when you place it in water. So if NO3 is a conjugate of a strong acid, it'll behave as a base, but in this case it does nothing. So therefore we're looking at the conjugate of some weak base on this. So if we're looking at, we know that this is a conjugate of some weak base, then it will behave as an acid. So when we look at our overall reaction equation here, you'll notice that yes, this does have a +1 because again, nitrate's -1, and this has to be a +1 for the whole thing to equal no charge. Don't forget about the charges here. So when this actually is placed into water, what's going to happen is a hydrogen is going to drop onto the water, forming hydronium, the H3O+, and then we'll be left with our neutral weak base. So this will cause the solution to become more acidic. Looking at CsCl4, okay? Again, ask yourself, what do I have? So the cesium is a conjugate of a what? That's right, it is a conjugate of a strong base. So this part of the molecule will do nothing when placed in water. The ClO4 is a conjugate of a what? It is a conjugate of a strong acid. Therefore, when we place this salt in water, it will dissociate 100% into these two ions, which will cause the solution to remain neutral. Nothing will change pH-wise here. Number 7, we have KCN, or potassium cyanide. Again, take a look at what we're looking at here. So the potassium is a conjugate of a strong base. The CN, and you do not need to know the name of that, the cyanide, you don't, that's not one of your 10 polyatomic ions that you need to memorize. Make sure you do know those. But the cyanide behaves, or I'm sorry, is a conjugate of a weak acid. Therefore, conjugates of weak acids behave as bases. So when we dissociate this thing, it'll dissociate 100%. The potassium will do nothing, but the cyanide, when placed in water, will rip a hydrogen off and stick that hydrogen right on the front, and leave behind hydroxide. So this salt will cause the water solution to become basic. I hope this has helped. I promise you'll see some salt questions, most likely on the multiple choice section of the AP exam, at least one or two. Make sure you also know your solubility rules. If you don't know your solubility rules, you really need to know that, especially for question 4 and for your precipitate lab question, which has happened for the last 2 or 3 years, so I expect it to be on the test again this year. I hope this has helped.